So we just did mutable. This one is very similar. It's like we did read-only and deep read-only, mutable, and now we're doing deep mutable. So this is kind of what it looks like. You're gonna get an input that could have any number of read-only modifiers at every property, and you're gonna return something from the type that has no read-onlys anywhere. All right, and it says you can assume that we're only dealing with objects. Arrays, functions, and classes don't need to be taken into consideration. However, if you want to challenge yourself, we're not gonna challenge ourselves. Okay.
We're not gonna challenge ourselves.
No, not this time. So this is the cases up here. I don't think I need to, hopefully not need to show them too much, but it's like we take this as an input and we get this as an output, right? It has all the properties read-only, including a deep one, and all the properties here are not read-only, they're mutable now. So let's go here and we start. Rob, what do you think?
All right, so much like the mutable implementation before, in the map type, it's a recurring theme in these.
It is yeah. The map type thing is pretty powerful. You can do some pretty wild stuff with the map types. Key of T. Right.
Let's try this. Type. All right, so this is only the shallow mutable. So we're gonna do the read only here.
Yep.
So let's do this. If this what was that trick we did for the deep read only? It was key of this
extends objects.
Extends never.
Oh, okay. All right.
Never. Oh wait. T or we recurse.
Oh, you're going off the screen here. Let me grab this. There.
Not satisfy the constraint objects.
Right.
Oh, interesting. So this is saying that it's
and let me grab that graph that we were looking at before. So while Rob's thinking on that, I'll show people. We looked at this at one of the, I think it was the deep read-only example, actually. This came up again.
Yeah.
But this is a graph showing what you can assign to from what. So like, is null assignable to this thing? I don't want to put a name on it because it looks like an empty object, but it isn't quite that in TypeScript. Is null assignable to it? No. Same thing here. Is string assignable to this thing? Yes. So there's this thing. It's from, I think this is an abbreviated version of what the TypeScript ESLint rule on this says. You can assign anything to this curly brace pair except for null and undefined. Whereas for object, lowercase o, you can assign anything that's not a primitive to object. So primitives are strings, booleans, numbers, big int, symbols, null, and undefined. You can only assign objects, like the thing we think of when we say objects. Like, I know that arrays and functions are technically objects, but the thing that we think of, you can only assign that to record with a string and string values and string keys and unknown values. So that's a useful thing to have in our little tool belt. All right, that's enough for that intermission. What'd you come up with, Rob, here?
Interesting. All right, so now I removed the objects constraint here because we're handling in the value.
Well, then we're not going to pass these guys.
No, but because it handles that case now.
Right, but this is expected to be an error.
That's just silly.
It's just silly. So we have to keep that in there.
We can do this.
You're really close though. Can I show you? Let's
Absolutely.
see. So if we switch these guys here, oops, it'd be like that. Yeah, exactly. And then we do this. Oh, we don't need that anymore. I think this is here.
So where is this?
Right. I was just talking about this down there. Okay. It gives you this with object as like an entry point. This is the part that gets a little screwy. So you need to do extends record string any. Do you get why? Because it's like saying here, let me just reformat this for a second. So it's like saying what do we have here? Test2. What's wrong with test2? Wait.
Let's take a look at test2. So we've got a function here.
Let's type. Type.
Wasn't there like an or call?
Oops. Test2. Oops. We want to do this DeepMutable. This guy. So let's look at it. They're all. Oh, it shows me the input.
Like this.
Did you figure it out?
Here. And we have to get rid of the function.
Oh, right. So on that note, okay, let's actually jump straight to an alternative. I think I messed that one up, but this one is definitely not messed up.
Yeah.
So let's read through this. It looks pretty scary, but it's not that bad, and I annotated it with some comments. So from the top, we have DeepMutable, and it takes a T that extends object. This part extends object, excludes these guys over here, right? Yeah, you're fixing my function thing. I learned something today about the function keyword. Yeah. Thank you. So this whole thing is one object. Like, this is the keys part of the object, and this is the value part of the object. You see what I mean? So we're subtracting read-only indiscriminately at all times. Wait. No, we don't want to do that because it goes off the screen. I had it all planned out, Rob.
Just lining up the comments.
Okay, so TP extends object. And again, if we look down at our thing here, that means we're only getting these that are going to extend object. Functions, arrays, and like regular objects. So if it extends object, like lowercase o, then do something. Hold on that thought for a second. But if it doesn't, you know what that means? It means we have all this other stuff, these other things that are not objects. Well, for those things, they don't have a read-only or a mutable or whatever-ness to them because they're just plain literals. So we can just return them. So TP is that value. We can just return it. Great. Now we have to condense one level deeper. We say, does the value extend function? Basically, this is args unknown. Returning unknown. This is like function. So if it does, that's fine. We also want to return those because functions don't recurse, right? You can't go into a function like you can with an array or an object. But if not, then what we're left with is these bottom four rows here. You know, we're left with arrays and objects. Well, arrays and objects can be recursed, so they can be mapped in here in the values of these types. Using this syntax with the brackets. So then we just keep going. We go down the path. Eventually, all of these will terminate here, which is the base case, and then we're going to get all the values. We don't want to filter anything out, so there's not a place here where we're like excluding or returning never or anything like that. There is a nope that I want to show that I saw. I saw a couple people online trying to do this, and this is the place where, or one of the places where it fails. Is like, it's hard to know. You know, I understand that people might want to think like, oh, okay. I
think the empty interface means an object.
Means an object, yeah. That's what you're kind of thinking when you write it. It just doesn't mean that in TypeScript, for better or for worse. It means, well, you can consult this chart to see what it means. But yeah, that's DeepMutable for you. It's a pretty spicy meatball, if you know what I mean. And I think it's kind of cool to see these concepts and see how to problem solve through these things. Hopefully it makes sense. Any other thoughts on this one, Rob?
With great power comes great responsibility.
You're talking about mutability, are you?
Yes.
Rob is a big fan of functional programming. And what's that language you call? Or you use Rescript? Right. I don't know because nobody uses it except you. Are you the only person on Earth that uses it, or is there one other?
Absolutely. Yeah.
Rob, thank you for coming on, and it's been fun. And hopefully we'll do more of these in the future.
Thanks for having me.
Bye, everyone.